welcome back everyone. And we're going to look today at graphing linear inequalities. So as a reminder, again, take this opportunity to print the guided notes from Google Classroom or pause here and create your own in your notebook, just like I would have printed out for you, and the blank copies are all on Google Classroom. So let's do a quick review, because we've done lots of graphing just regular inequalities before. And so here we've got an example of that with x is less than or equal to 4. If you remember, we go through a couple, three specific steps when we graph inequalities. The first one is to plot the boundary. So if we're looking at our line, our boundary here is 4. And so we're just going to draw a point at 4. Next, we have to decide if that boundary is open or closed. Now, to decide that, we want to look at our inequality sign. And here we see it's or equal to. So that means it is a closed boundary, meaning we are going to fill in this dot here. So closed again means filled in, and that means it has an or equal to sign beneath it. Open is greater than or less than. The third step we have to do is decide on shading. So with the shading, we can either be shading to the left of the boundary or to the right of the boundary. In this case, we see that x is the less than sign, and so then we are shading in the numbers that are smaller than 4. So with shading, you're looking for less than or less than equal, or greater than or greater than equal. So hopefully this feels pretty familiar, but take a second to review and practice. If you're not sure, you can go back and look at old notes. So here's an example of a linear inequality, meaning that we have an inequality here, we have a less than sign, but instead of just a number, it's a line. So the boundary is going to be in terms of mx plus b, just like the lines that we've seen before in slope-intercept form. So if we're looking here, we see that we have our slope here and b. So when the first thing we do, as it says, is plot the boundary. So I'm going to put in some of the points for the line. We've got +2 on our y-axis, and then it goes down 4 over 5, which gives us a point right here. I'm just going to draw in a couple more points. There's a reason I'm not drawing in the line, and you don't have to either right now. So once we've got a couple of points in there, let's talk about open or closed. So with open or closed, we're still looking at the inequality symbol. Open, in this case, meaning that it doesn't have an equal, or closed, meaning it does. For a closed boundary, you're going to make it a solid line, and for an open boundary, you're going to make it a dotted line, like this. So in this case, you'll notice it's open, and that's why I said don't worry about filling in things right away, because we're going to make it a dotted line, not a solid line, since we're looking at an open boundary. It is a line, so make sure you put the arrows on the end. Lastly, with shading, we're looking at above or below the line, above being y is greater than or equal to, and below, I wrote x, meaning that y is less than or equal to. So in this case, it's y is less than, so we're shading below the line, meaning if we take any part of the line, and we should be shading below that. And you don't need to be super careful about drawing it all in. This is thoroughly adequate to show that you understand which side of the graph is the set of solutions versus the other. So this is perfectly neat enough. Just make sure you're not crossing that line. So here we've got another problem, just as a nice way to review this. We don't have a constant here for a b term. So if you want to rewrite it in slope-intercept form, we would have over here 2 over 1 to create a fraction for our slope, rise over run, x plus 0. So this can be a really helpful way to keep everything organized, rise and run. And then we've got our b here. So if it's plus 0, it means it's going through the origin, just like the proportional relationships that we saw yesterday. And then up 2 over 1. And I'm going to draw in the next couple points. There, there, there. A couple on that side. A couple here. And now I'm making the decision about open or closed. In this case, looking at the inequality, it's got the or equal to sign underneath. So that is a closed boundary. So I'm going to draw a solid line here. Again, putting the arrows on. And then shading, y is bigger, so everything above the line. So if I take the line and I shade above it like this, once I've got a pretty good idea of what side I'm looking at, I can just start scribbling in. Again, I'm not expecting perfectly colored in spaces, but a clear sign that you know which side should be shaded and which side shouldn't. After looking at those two examples, please feel free to, as always, leave questions in the comments below, and I will get to them as soon as I can, or maybe even one of your classmates will jump in and help. All right, so some other types of questions that we could ask about linear inequalities is to tell whether a point is in that shaded in region. So if we're just looking at a brief little graph, the question is a point in this region? And you can draw this out and ask yourself, or you can do it algebraically, because if the point is here, that's a great solution. If the point ends up on this side of the line, in that case, not so nice. So, but you can also solve this algebraically, because if we're looking at an ordered pair, what this tells us is that -3 is equal to x, and 9 is equal to y. And since we have an equation with those, we can substitute those in. So using the equation, replacing our y, we get 9 2/3 x, which is -3 plus 11. And then the question is just, is this true? And we can do some simplification over here. We end up with 2/3 times -3 is -2 plus 11, which is 9. And then the question becomes, is this now a true inequality? And the answer is no. If this had been greater than or equal to, it's important to know, if it had been greater than or equal to as the inequality here, this would be a solution, but since it's strictly greater than, this is not a solution to the inequality. We also might have problems with word problems. So we see some like this. The sum of two consecutive numbers is less than 40. What is a pair of integers with this property? So as a reminder, consecutive means one after the other. So an example would be, 3 and 4 are consecutive, -30 and -29 are consecutive because they just come in order, one after the other. The way that we might write this algebraically is x, and then the next one after that would be x plus 1. So hopefully you notice here 3 and then 4 is 3 plus 1, plus 1, plus 1. So with a question like number 5, there are infinite possible answers here, because all it just needs to be is less than 40. 1 and 2, 3 and 4 that I used here, and -30 and -29 both work. And there's infinite others as well. But all you need to do is recognize that some of them, because all you need to do is know that their sum is less than 40, meaning they add up to less than 40. Now, a more challenging question is, what is the pair of integers with this property that has the greatest sum? So what's the biggest it can be without going over 40? And you can do some guess and check, or you can set up an inequality where you've got your two unknowns. So I'm going to call x, and then as a reminder, the consecutive number after that is x plus 1. So here's our first number. Our second number is less than 40. And now we have an inequality we can solve. 2x plus 1 is less than 40. Subtract 1, divide by 2, we get x is less than 39 over 2, which is 19.5. Now, since x can't equal 19.5, x has to be less than 19.5. So then x is going to be 19, because we're talking about integers, meaning whole numbers. So if x is 19, that's the first number, and the consecutive number after 19 is 20. So this would be the largest it could be while still satisfying that inequality. So make sure, as always, to leave any questions that you have regarding your assignment for the day. Make sure you've done your check-in if you haven't already, and make sure that you've put in any homework questions into the form from yesterday's if you got stuck on anything, and I'll make sure that I post videos about the high voted ones and maybe just get back to you individually if you're stuck on any one from last night. All right, have an absolutely wonderful day, and I'll talk to you tomorrow.